We've already seen that linear equations take the form of y equals mx plus c, or ax plus by plus c equals 0. However, there are two special linear equations that don't fall into those categories. Well, actually, one of them does a little bit, the top one. So what does the graph of y equals 3 look like? There's no m, there's no x, and we've just got y equals 3. So, as I say, it looks a little bit like this form, gradient intercept form. So in this case, c is equal to 3 in the gradient intercept form. So if we go back and have a look, 3 is where it cuts the y-axis. So we know that that point there, at 3, is going to be on our graph of y equals 3. But no matter where we go for x, if x is equal to 6, y is still equal to 3. There's no x is going to change the value. So no matter what the x value is, so if we go from 0 all the way up here, y is always going to be equal to 3. If we start at x equals 0 and put x equals minus 1, minus 2, all the way down to minus infinity, we will get y equals 3. So why did we just put dots? Well, I don't know. So we're just going to have to put a straight line to include not just intermittent points, but every point. So that is the equation. There's my x-axis. Here's my y-axis. So this is the equation of y equals 3. It is parallel to the x-axis. If you like, you could think of it as m being 0. It's got no rise. It's got plenty of run as you go across, but there's no rise. So m is equal to 0. If you put m equals 0 in this, doesn't matter what the x value is, 0 times whatever number is going to be 0, so you just get y equals c. So graphs of the form y equals c, and c could be negative, so let's just put it down here. So here's my x, here's my y, and this is y equals c. In this case, obviously c is going to be a negative value. So there's one of our special ones. What about the graph of x equals negative 2? Well, let's draw a set of axes. And let's find the point negative 2. So x equals negative 2 is certainly going to be that point there at negative 2. So here's my x and my y. That's 0. So x is equal to negative 2. If y is equal to, if this is the equation of my line, if y is equal to 6, what's the value of x? X is still equal to negative 2. It doesn't matter what value I give y, x is always going to stay at negative 2. So I get a series of points of the ones I substitute, but why not just do whole numbers? Why not do decimals, and why not do thirds? And we'll get the whole number line, so we get this. So that's the graph of x equals negative 2. Now, just be careful. If you add 2 to both sides, we get x plus 2 on the left. Adding 2 to both sides would be 0. So sometimes you see it like that, and that tends to stump a few people. But that's still the equation can be rearranged to x equals negative 2. Similarly with the y up there, you can get y minus 3 equals 0, and that's the same as y equals 3. So if you get something equals 0, just turn it over to make it look like this. Alright, so there's two special equations. Y equals and x equals. Once the y equals is parallel to the x-axis, the x equals, no matter where it is, will be parallel to the y-axis.